Okay, we're going to finish up with a short talk about surge protection devices and their use in PV systems. So, surge protection devices, SPDs. Here's a couple of examples of some plug-in type surge protection devices. Here's one that is in an inverter. Here's one that is mounted in a combiner box. And these are essentially to protect equipment from surges due to lightning, which may be direct or induced. It doesn't have to be a direct hit. A nearby strike or even cloud-to-cloud lightning can induce significant currents and the transient overvoltages that occur as a result. It could also be due to a spike on the utility grid, either from heavy loads that are nearby or from lightning strike on the grid or from high voltage lines falling on lower voltage lines, whatever that may be. The grid is certainly one of the sources of surges as well. So we want to take care to protect our equipment. When we have a surge, we have this transient overcurrent situation that's happening, and that leads to overvoltage, and that can cause damage to electrical components as well as conductor insulation that can either be catastrophic or it can cause damage that over time leads to more rapid degradation and failures that then occur. So there's a lot of different locations that these devices can be installed. Right? One option would be something we would call like a whole house surge protection. This would be maybe in your AC service panel. We see a lot of inverters that either have integrated surge protection devices or the option to have them integrated either on the AC side, the DC side, or both in terms of that particular piece of power electronics. As we see on the slide, certainly in combiner boxes as well. Data acquisition systems are another common place for surge protection devices to protect the equipment in there. And essentially what these are doing is they're acting as a very high impedance device that's connecting current carrying conductors to ground. So there's no circuit there because of the high impedance in the device. When there is a surge, that high transient voltage that occurs turns the surge protection device, causes it to flip into a very low impedance device, which allows that current from the surge to be shunted to ground. So it protects the connected equipment as a result. Now, when it does that, it usually needs to be replaced. And we'll look at some examples or an example on the next slide where there's one that clearly indicates. It might be a little hard to see here, but that, believe it or not, that's green good. We'll see one where red is bad, and meaning it's done its job. Now, a lot of people right off the bat, they're like really super worried about lightning and solar. And a lot of people think they live in very lightning prone areas, even when they don't. And there's some areas of the country where there's a lot of lightning at certain times of the year and not others. And there's some areas like Florida where there's maybe a lot of lightning all the time. And there's other areas where there's hardly ever any lightning. Hardly ever any. So don't want to overemphasize the risk here necessarily. Does it make sense to protect our equipment? Definitely. Is it not something we need to freak out about? We don't need to freak out about it, right? Because even the manufacturers of these devices are going to tell you that the best protection is a well-grounded system. What we really want to do is we want to make sure that all of our metal is connected together, that we have a proper connection to the earth itself. The more we make our system look like the rest of the planet in terms of being bonded together and grounded to Earth, the less likely it is there's going to be any reason for lightning to hit it. It's just becomes more of the luck of the draw at that point. And then what are you going to do? Stuff gets hit by lightning sometimes. Well, the more solar there is, the more likely that's going to happen. But we can take some steps before even thinking about surge protection devices that can help our system out. And having that well-grounded system is key. If you have a poorly grounded system, right? If I haven't bonded my equipment correctly and I don't have a good connection to the earth and maybe my grounding electroconductors are undersized and whatnot, well, no matter how many surge protection devices you throw at it, it's still not going to fix the problem. The other thing I want you to keep in mind here is this is not lightning protection. Lightning protection systems are a completely different subject. The National Fire Prevention Association that publishes the NEC has a whole nother standard on lightning protection systems. Lightning protection engineering is a specific trade. There may be times when you need to integrate with an existing lightning protection system on a building. We're not getting into that in this course, but that's not what surge protection is about either. These are devices that we use to protect either an entire system or particular circuits in a system from these transient surges from lightning or spikes on the grid. So some of the things to keep in mind, and as I said, here's the example of a couple on the left. You can see these are PV surge protection devices. Red bad, red replace, green good. These used to be green. These are the plug-out cartridge style, so you don't have to unwire it. You unplug this, pop a new one in, and we're good to go. Some of them aren't that way. You have to replace the whole body, which means disconnecting these conductors, which are energized, right? Here's a positive, here's a negative. They're connected to a bus bar and an inverter or a combiner box. They are connected through the high impedance surge protection device to ground. And if there is that transient over voltage, transient over current, then we get our circuit become much lower resistance and current can flow through there. Here's another type of PV-specific surge protection device mounted on a combiner box as well. Lots of different options out there, but things we want to think about are the amp suppression and voltage type and rating. Of course, it's going to need to match the system that we're installing it in. Is it a DC circuit? Is it an AC circuit? What is that voltage level that we're dealing with? The visual indicator is a great thing to have. Most, but not all of them have that. There are other options too for remote enunciators where it could be tied into a data acquisition system and give you an indication that, hey, there was a surge, time to replace the device. These are connected, as we've kind of said, in parallel to the circuit that's being protected, right? We run each of the current carrying conductors to it, run a grounding conductor to it, and that's the manner that they're installed. A lot of times, if these are built into stuff like inverters or charge controllers, there's no need for you to wire up the surge protection device. It's already built in. Maybe you had to select it as an option, but we're not installing it. And in other cases, you may be. The surge protection devices on the right side here, those were installed separately by the installer, not the manufacturer. And the different types of installation, right? The ones on the left, DIN rail mount. You can see the DIN rail back there that they clip onto. These ones mount through knockouts with lock rings on them instead. And as I said, often these are built into some combiners and inverters, or at the very least available as an option. All right, that's a quick look at surge protection. I hope you enjoyed the presentation. I will catch up with you again in another lesson soon. Thanks.